Good day. This video is going to focus on learning target 4 in topic 1, and there are two listed here. The first one is I can convert repeating decimals into a rational number. So basically you're taking the decimal form and putting it into a fraction form. And the advanced learning target is I can explain the patterns that exist when doing that. So hopefully after you do a couple, then you'll be able to see a pattern that happens, and you can express that pattern by explaining it to others. Now, there is a little bit of mistake here. We do not have notes and homework specifically on the Advanced Learning Target 4, so you could cross that off. So let's go ahead and move on with Learning Target 4, converting repeating decimals into a rational number. I am going to walk through this example that is completed for us, and I would like for you to follow along as I talk. So the key concept is that all repeating decimals are rational numbers, which means we can write them as a fraction. So you can use algebra to write a repeating decimal as a fraction. So the example that's completed for you already is writing 0.72 repeating as a fraction in simplest form. So the first thing we do is, in this example they use an n. It doesn't matter what variable you use. I might use an x because that's typical for me to use, but you can use any variable. So you let x equal the number that you're given. In step 2, we have two decimals that the repetend is over, 7 and 2. Because there are two decimals, that's why I have two zeros right here. If only the 7 repeated, then you would only have 1 0, so you would multiply by 10. And we'll go through an example like that in just a minute. So since it had two decimals repeating, we are going to multiply by 100 on both sides of the equal sign. So 100 times n, and 0.72 repeating is multiplied by 100 as well. So on this side we still have 100n, and if you multiply this number, 0.72 repeating, by 100, I'm going to write that out a little bit more for you. So 0.72 repeating in a longer form is 0.727272, and it goes on and on. So what we're going to do is multiply by 100, and if you remember the shortcut, multiplying by 100 means you move the decimal 2 places over. So that's where I'm getting this 72.727272, just like that. When you move the decimal point over, that's what's left. So that's why I have this is equivalent to this. Alright, step 3 is to subtract the original equation, this one right here, from our new one here. So we have the new one, which is 100n equals 72.72, and we're missing a couple things, so please add these in with me. You should have 3 dots after that, and you should have 3 dots after that. That's really important, and that's a mistake on my paper there. So these 0.72 repeating forevers right there, and this 0.72 repeating forever, we are subtracting. We are subtracting. So we're subtracting n on the left, and we are subtracting the 0.72 repeating on the right. So all of this repetition here will cancel out. And that's how I am left with 72, because we have 72 here minus 0 here. After the decimal points, cancel everything out. 100n, and then I'm going to put in here minus 1n. 100n minus 1n is 99n. And now we are ready for step 3. To get n by itself, we would divide both sides by 99. So that's what I did there. And then the last thing, 72 over 99, is not simplified. There's a number that goes into both 72 and 99, which is 9. So to simplify the fraction, we divide 72 by 9, and that's where I got the 8. And we divide 99 by 9, and that's where I get the 11. So 8/11ths is the final answer. I would imagine it'll take quite a few tries to get the understanding of this process down so that you are independent with it. So let's move on to the examples that I'll walk through from beginning to end. So we're going to start with writing 0.4 repeating as a fraction. So if you think about what numbers repeat, it's just the 4. So the first thing I'm going to do is I'm going to write n or x equals point, and I'm going to choose to write it out a little bit longer. And the 4's continue to repeat. Step 2, since there's only one digit that repeats, the 4 is the only digit that repeats, we're going to multiply by 10. Because one digit repeats, we have 1 0. So 10 times n is equal to 10 times 0.4 repeating. So let's simplify that right-hand side there. So we have 10n on this side is equal to, when you multiply by 10, you only move the decimal once. So that's going to be 4 point, and then the 4's repeat here. Now the third step is to take that result, 10n is equal to 4.4 repeating, and subtract the original n. So we're going to subtract the original n, which is 0.44 repeating. So subtract the original there. When we do that, 10n minus 1n is 9n. And on the right-hand side, the 0.4 repeating here subtracted by 0.4 repeating here cancels out. So we're just left with 4. So now we have 9n is equal to 4. We need to, step 4 is to divide both sides by 9 to get n by itself. So that leaves us with n is equal to 4/9. So that's the answer. We want to think about if 4 over 9 will reduce or simplify, but it doesn't. There is no number other than 1 that goes into both 4 and 9. So 4/9 is my answer. All right, let's try another one. We're going to start by setting n equal to 0.45455 repeating. Step 2 is to multiply by 100. I choose 100 because there are 2 digits under the repetend, so I multiply by 2 zeros in that number, so 100n, which means I move this decimal point 2 places over. So I get 45.4545, etc. Step 3 is to subtract that result in step 2. 100n equals 45.45 repeating. subtract that by the original. So subtract the original, 1n is equal to, and we're going to subtract the 0.5 repeating. So 100 n's, take away 1 n, leaves us with 99n. And then the 0.45 repeating here, take away the 0.45 repeating here, cancels out. So we are just left with 45 over here. Then we need to divide both sides by 99 to get the n by itself. So that leaves us with n equaling 45 over 99. But this time there is a number that goes into both 45 and 99. They are both divisible by 9. And so when you divide both top and bottom by 9, we get 5 over 11. And a good thing to do would be to do 5 divided by 11 in your calculator and make sure you're getting the 0.45 repeating that we started with. That concludes the examples that we are doing on the video together. Now it's time for you to practice on your own.